How to Classify Linear and Nonlinear Differential Equations by Angel Jauregui, Math 24, Section 04, Fall 2020. Linear versus nonlinear. The trick for classifying linearity in differential equations is to focus on the dependent variable. Here we have a dependent variable, which is Ry, and we have a constant, which is P of t, and as our order goes up, we will have added constants as our differentiable as our order increases. So increasing the order here is just adding another derivative and another constant. So as long as the dependent variable or the y in this is not accompanied with any exponentials, trig functions, squares, or square roots, this example will be linear. So we have examples. For these examples, so no trig, we got to follow these rules. So for the first one, we have no trig, no exponentials, no squares, and no square roots, which makes this first example a linear. For example number 2, we see that we fail already by using a square. We can't have squares, so this is going to be a nonlinear. For the third example, we have a trig, and we can't have trig. And everything else looks good, but no trig, so this is going to be nonlinear. We have other examples. These may look different because there's more than one dependent variable, but same rules apply. So for the first one, we have 4x minus 3 to e to the x is 15. We have an exponential. We can't have exponentials, so this one is non-linear. 4x minus 2y plus square root of z is equal to 12. We have a square root here, and we cannot have square roots, so this is going to be nonlinear. This one looks good. There's no squares, no square roots, no exponentials, trig. This one is going to be linear. So here's the breakdown of y. E to the x is exponential. This is a square root. So these are, the first two are nonlinear, and the third one is linear. So if we were to graph these, linears look like that. So this is linear, and nonlinear is going to look with a curve, something like that. So my resources, I use the book, and I use Desmos for graphing. Thank you.